Welcome to the topic. Here's a comprehensive breakdown of the image provided. Header, title, evaluate int cos²x sin3x dx. This breakdown clearly explains the steps involved in evaluating the integral and the transformations that will be applied. Let's get started. To change this integral into a more manageable form, we can use the identity sin²x equals 1 minus cos²x. This will help us evaluate the integral efficiently. Let's define u equals cos x. This implies that du sin ex dx. Using this substitution, we can express our integral as in cos² x sin3x dx into cos1 minus cos x dx. Revising our integral further gives us is into u to 1 minus u caret du. Next, we expand the integral with c form du. The integral can now be calculated as mouse left f5u5 minus 3u3 right plus c. Finally, we'll substitute back u equals x, or equals frac 1 5 chi of quantity x plus c. This breakdown provides clarity on the steps involved in evaluating the integral and arriving at the final expression of int cos x sin²x dx, which results in equals frac 1 5 cos 5x minus frac 1 3 x plus c. Well done. Thank you for watching this breakdown. We hope this was helpful for your understanding of integrals in calculus.